Okay, so we're going to be talking about gases today, and we're going to start by talking about where the word gas comes from. So it comes from a Dutch form of the word chaos. Gases were actually the last form of matter that were easily understood. And if you think about a gas that we're exposed to every day, it would be air. Air is made up of mostly nitrogen gas and then some oxygen gas. There are small quantities of other gases mixed in with it, things like carbon dioxide, argon, helium, and the air that we breathe is an example of a homogeneous mixture or solution because gases uniformly mix with each other. And some of the special properties of gases will be that they expand to fill their entire container. And most gases are colorless. Many are odorless. Gases tend to have very low densities. Okay, so that's why gases tend to rise. And then gases will mix uniformly in any proportion to form solutions. So gases are going to appear the same throughout. Now, the volume of a gas is going to be dependent upon the pressure and the temperature. We will talk more about that when I get to the next section. And let's take a look at the next page. We can use something called a barometer to measure the atmospheric pressure. So all of the gas that is in the air above you exerts a force on your body and everything else around us. So we call this the atmospheric pressure. You will often see the atmospheric pressure abbreviated as a capital P with a little subscript ATM on the right-hand side of it, okay? And when we measure the atmospheric pressure with a barometer, some classrooms will have a barometer in them. We don't have one, but you can also Google the atmospheric pressure at the current time on the internet. Okay, so the barometer was designed by an Italian scientist by the name of Torricelli in the 1600s. And there is an image of a barometer in your book. It is a glass tube that's sealed on one end, and they inverted it and put it on top of a glass dish that contains a liquid. Typically, that liquid is mercury. So what happens is when the air around a barometer is pressing down on the barometer, it causes this liquid mercury to rise and fall in this glass tube. And then you read the level of the mercury in this long tube in millimeters. So that's where we get the unit millimeters of mercury for pressure. Okay. And something that you should know is that when you're at sea level, they define the height of mercury in a barometer as standard atmospheric pressure. So standard atmospheric pressure is going to be the measurement of the mercury column at sea level. At sea level, we define the elevation as being 0 meters. Okay, so 760 millimeters of mercury would be considered standard atmospheric pressure, and we can use this and all of its equivalencies to perform unit conversions. God bless you. And let's take a look at the next page at manometers. So another way that you can measure the pressure exerted by a gas is with a manometer. Now, the main difference between a barometer and a manometer is that a manometer is has a closed container with a gas in it attached to a U-tube, and the U-tube is filled with some liquid mercury. Okay, so let's take a look at the next page at what this looks like. So what's useful about a manometer is that if you have the atmospheric pressure, which is pressing down on the open end of the U-tube that's attached to this container, we can use that to help us determine the pressure of the gas that's in the enclosed container. Okay, so when the two levels of mercury are the same in the U-tube, that's when the pressure of the gas in the enclosed container equals the atmospheric pressure. Okay, if the atmospheric pressure is pressing down more than the pressure of the gas in the container, obviously the mercury levels are going to be different. Okay, so here the atmospheric pressure is greater than the pressure of the gas, and you would have to calculate the pressure of the gas in this enclosed container by taking the atmospheric pressure, and then you would subtract whatever this difference is in the height between the two sides in the U-tube of the liquid mercury. If the pressure of the gas, if this is pushing more on this liquid mercury than the atmospheric pressure was over here, that means the pressure of the gas is greater than the atmospheric pressure, and you'll add this distance between the two heights in the liquid mercury and the U-tube to the atmospheric pressure to get the pressure of the gas. So let's do a couple of sample problems just so you can kind of get an idea of what this looks like. Let's come over here to the next page. So number one wants us to use the two devices that they gave us to measure the pressure of the gas that's enclosed in the Erlenmeyer flask. This first image here, A, this is the barometer. They're giving you the barometer so that you can read the atmospheric pressure under these conditions. So here it says that my atmospheric pressure is 765 millimeters of mercury. Okay, so I'm probably going to use this to do B. Okay, then in B, we've got some gas in this enclosed Erlenmeyer flask, and you can see based upon the levels of the mercury in the U-tube, this gas is pushing more on the mercury than the atmospheric pressure is. So that means that if you want to calculate the pressure of the gas in the enclosed container, you're going to need to take the atmospheric pressure and add it to that mercury distance. So our atmospheric pressure was 765. And then this height here is 135 millimeters of mercury. The only thing that you need to be concerned about here is making sure that your units match. And here they do, right? Both of them are in millimeters of mercury, so that means you can add them together. Somebody add this up for me. What is this going to be, 900? Okay, so this is 900 millimeters of mercury. Okay? We good with this? No problem? Okay. Now, let's move on and let's talk about some gas pressure units. You're going to be converting in between things like torr, atmospheres, millimeters of mercury. I will give you the equivalencies. You don't have to memorize them. So let's take a look down here at the different units for pressure. So it was considered to be awkward to write millimeters of mercury. So that unit is often called torr in honor of Torricelli. There's another common unit of pressure, pounds per square inch, which is abbreviated as PSI. And then the international unit for pressure is actually the Pascal, which is named after the physicist. And then a Pascal is 1 Newton per square meter. That's something that you may use if you go on to physics. Pascal is a really, really small unit. And then sometimes they may use kilopascals instead. And then down here, this is what I will give you on a quiz and a test. Okay, so remember earlier how I said standard atmospheric pressure at sea level was 760 millimeters of mercury? So that means that all of these other equivalencies would be considered standard atmospheric pressure as well. These would all be at sea level. Okay, So you do not have to convert between atmospheres and then go to millimeters of mercury and then go to torr. You can skip over. So if you wanted to convert atmospheres to PSI, you could without converting to mmHg and torr first. Okay. All right. So let's take a look at doing a couple of these and then we're done. So let's go to the next page. I think it's like the last page. And let's take a look at number 3 here. Number 3 says the pressure gauge in a full scuba tank reads 206 bar. Convert this pressure to units of PSI, which are standard scuba units in North America. Okay, so we're starting with 206 bar. So that means you have to write bar on the diagonal so it cancels. And then you're going to write PSI up on the top. So I'm just going to highlight the units that have to match so that they can cancel. On the previous page, what are the numbers in front of bar and PSI?
In front of PSI is 14.7 and 1.01.
Okay, so in your calculator, this is going to be 206 times 14.7 divided by 1.01. Enter. You want to round your answer off to 3 significant figures. Tell me what you get.
3,000 with 3 sig figs.
3,000? Really? So I would need to put this as 3.00 times 10 to the third?
Yeah.
Yeah? Okay. We all agree? Yeah? Okay. All right. That's the end of this first section. Do you want me to keep going?